Hi, welcome to the Organic Chemistry Quick video. This is Alpha Carbon Chemistry Part 1, Carbonyls. In this class, we're going to split alpha carbon groups into two different parts. First, we'll talk about our carbonyls, which are any of our functional groups with a C double bonded O. That includes aldehydes, ketones, carboxylic acids, and carboxylic acid derivatives, and then everything else. This being the first video, we will be dealing with the first part of our carbonyls. Carbonyl chemistry is kind of unique. We have this really electrophilic carbon for two different reasons. First one is resonance. Resonance is going to exist with a carbonyl because we have a pi bond between two different atoms, and therefore one of them is going to be more electronegative, pulling the electrons up toward it, leaving the other one more positive. The other reason is just the simple fact of induction. And during induction, you're thinking about the polarity of the bond, and it's another reason for those electrons to be up more toward the oxygen, leaving that carbon showing a little more than maybe carbon's parents would like. Essentially, all of our carbonyl chemistry is going to happen in one of two ways. And these two ways are essentially the same, it's just what's happening first. So we're going to have a nucleophilic attack on our carbonyl because we've got a very nice nucleus hanging out. These can happen with strong nucleophiles or weak nucleophiles. Our strong nucleophiles are going to be negative, or they're going to have a spectator ion and show up as neutral. And then our weak nucleophiles are going to be positive, or they will have, or neutral, really, and no spectator ion. With our strong nucleophiles, we can occur under basic conditions. Actually, we need to happen under basic conditions. And then acidic conditions are generally required for our weak nucleophiles, because the first thing that has to happen is the protonation of your oxygen so that your nucleophile has enough of a running start to kind of get attached to that carbon as the electrons are being sucked up away from him. Strong nucleophiles don't need that acid, and in fact, sometimes the acid can cause a little bit of a problem. Right, so you've got a new memory book page. If you've already copied it from last semester, yep, I made another one. I rewrote the aldehydes and ketones to maybe make at least one of your classmates slightly more happy. Broke it out into three different sections: nitrogen nucleophiles, oxygen and sulfur nucleophiles, and then hydrogen and carbon nucleophiles. All of these do happen on aldehydes and ketones. I gave you the names of the product, the structure. Let's see, you should notice that the nitrogen, oxygen, and sulfur nucleophiles are all going to be occurring under acidic conditions, which mean that we have neutral or weak nucleophiles, whereas our hydrogen and carbon nucleophiles, those are going to be occurring under basic conditions because they are strong. Another thing to note is that almost all of our reactions that require a strong acid are also going to require the removal of water, because otherwise water will start to react with the products, and then you'll get making your way back toward something that you don't necessarily want to be going toward. And I'll show you the reaction mechanism here at the end. Carboxylic acid derivatives. Man, there is a lot of transitions on this slide. We'll leave them all up there. So carboxylic acid derivatives are compounds that will produce carboxylic acids when reacted with water. And I've got them listed on here from least to most reactive. Least is going to be nitriles. And then we've got amides, esters, and acid anhydrides, acid chlorides, and carboxylic acids. The nitriles I went ahead and moved into a little bit of a different section. If you want to see an explanation on that, watch the full videos. There are also carboxylates, thioesters, acetyl phosphates, and acetyl AMP. Those are also technically carboxylic acid derivatives, but we are not covering them in this class. I have the structures listed over here, along with the leaving group that we'll be leaving as we are reacting these. At the top, we've got carboxylic acid, that's our most reactive. And then underneath of that, as you start looking at those leaving groups, you should notice that you go from weak to strong base. So the conjugate acids at the top are strongest, at the bottom are weakest. Hopefully that made sense. So you make a carboxylic acid derivative into a carboxylic acid by adding water. Well, how do you make the carboxylic acid derivatives? Here's a cute little chart that may or may not be helpful. And then here's the reactions of carboxylic acids. I guess I put the nitriles up at the top there and didn't know where else to stick those little kids. There's a big pink note about when you're making your carboxylic acid. The rest of those are all some reactions with the carboxylic acid. Then here's all your carboxylic acid derivatives. I know this looks a little bit messy, but I tried making other ones that I thought would be better. Couldn't come up with anything. So on the left-hand side, you have a little bit of a key. These are your carboxylic acid derivatives from most to least reactive. Most reactive is the red box, so all of those reactions will happen on your acid halides. The next one down on your acid anhydrides, that's going to be any reaction that has purple around the reagents, and then for esters, it'll need a blue box around the reagents, and then for our amides, it's that one green box that looks like hydrolysis over there. All right, let's go ahead and take a look at the, whatever this thing is called, animation. Yeah, let's maybe head back toward the beginning. My bad. Now you guys are seeing behind the scenes. I went ahead and showed you with a basic conditions. With the acidic conditions, the only thing that's different is the protonation would happen first. So first, your nucleophile is attracted to that positive carbon, comes on up, makes that bond. And then last thing is protonation of your oxygen by whatever is handy. Usually it's going to be water. Again, if you are doing this in your acidic conditions, you really need to be removing that water. Otherwise, the water will come in and act as a nucleophile. All right, that's all I got for you tonight. Have a great night or day, whatever time it is for you.